Hello, Ramin.
Hello, ma'am. How are you?
Fine. How are you?
I'm good.
Great. कहाँ हैं बाकी लोग?
पता नहीं मैम आई नहीं अभी तक.
ये तो फिर अच्छी बात नहीं है ना?
Yes, ma'am.
आप लिंक पोस्ट करो ग्रुप पे.
Right, ma'am.
Ramin, have you started working on your paper?
यस मैम मैं रिसर्च पेपर्स कुछ पढ़ रही थी
Research paper? मेरी बात सुनो क्या?
और बुक जो हम सॉलिड स्टेट में पढ़ रहे थे कि उससे मैं कंटेंट ले रही हूँ.
अच्छा, आप रिसर्च पेपर्स ना पढ़ो, ठीक है, आप बुक में से ही प्रिपेयर करो तो ज्यादा बेहतर है, राइट?
राइट मैम.
अच्छा, तो बुक कौन सी पढ़ रही हो?
मैम वहाब की मैम ने सजेस्ट की थी और एक अली उमर शायद के मोहम्मद उमर उसकी थी.
अच्छा, आप ये
दो
वाली
बुक्स थी.
बुक भी लिख लो, चार्ल्स किटल.
किडल.
हाँ, किटल, KITTEL, चार्ल्स किटल.
राइट मैम.
इंट्रोडक्शन टू सॉलिड स्टेट फिजिक्स, ठीक है. अच्छा, इसमें आपने ख्याल ये रखना है कि एक और स्टूडेंट है, उसने टॉपिक लिया है क्वांटम फ्री इलेक्ट्रॉन थ्योरी, तो अब क्वांटम फ्री इलेक्ट्रॉन थ्योरी भी इसमें आती है, तो आपने इसके अलावा दूसरा कोई टॉपिक देखना है, ठीक है. क्वांटम थ्योरी ऑफ सॉलिड्स में तो बहुत कुछ आ जाता है ना.
यस मैम.
ये तो एक बहुत ब्रॉड वो टॉपिक है ना, तो उसने एक पर्टिकुलर टॉपिक लिया है फ्री इलेक्ट्रॉन थ्योरी, तो आपने फ्री इलेक्ट्रॉन थ्योरी के अलावा कोई और स्पेसिफिक इसके अंदर से देखना है, ठीक है.
ठीक है मैम. कोई भी एक स्पेसिफिक टॉपिक मैंने सिलेक्ट करना है फिर उसका.
मतलब ये सॉलिड स्टेट में ही आएगा, लेकिन उसमें बहुत से टॉपिक्स हैं जिसमें क्वांटम के कॉन्सेप्ट, ठीक है.
यस मैम.
ये चार्ल्स किटल की बुक में से आप देख लेना.
राइट मैम.
ओके, एंड स्टार्ट वर्किंग ऑन इट बिकॉज दैट्स द नेक्स्ट डेडलाइन. ठीक हो गया?
मैम.
अच्छा, और आपने वो असाइनमेंट कर ली?
नो मैम अभी स्टार्ट करनी है मैंने 1 o'clock पर.
ओके, एंड Mahnur. Hello,
Yes,
Mahnur.
ma'am.
How are you?
I'm good, ma'am. How are you?
I'm fine. Okay, so you've taken the topic quantum tunneling. So have you started working on it?
Ma'am, I will start today, inshallah. I was working on the assignment that you gave.
Have you submitted the assignment?
Yes, ma'am.
Okay, good. Okay, right. So, और बाकी लोग कहाँ पे हैं? मतलब what's the problem? Why aren't you guys coming? So I'm going to start, I think. ठीक है? Okay, now you can see my board, right? ठीक है?
Yes, ma'am.
Okay, fine. So we were talking about angular momentum and the operators associated with it. Last time हमने क्या पढ़ा था?
Ma'am, angular momentum in spherical coordinates, I think.
Spherical coordinates में, and then we talked about its operators, and then we talked about Lx, Ly, and Lz, है ना? इसकी हमने derivations की थी last, right?
Yes, ma'am.
Yes, ma'am.
Okay, so today we are going to talk.
Yes, ma'am.
So we're going to determine the value of L squared in spherical polar coordinates. Okay, so L squared means what? L squared is equal to Lx squared plus Ly squared plus Lz squared. So what will be the next step?
Ma'am, plugging in the values we found
Yeah,
last time.
we have the values for Lx, we have the values for Ly, we have the equation for Lz that we did in the last class. We are going to plug in those values. So please do that. So in the last class, we derived these values. So this was the expression for Lx. And then the expression for Ly was, okay, wait. This bracket was not here. It was, okay. So this is h bar over iota cos phi. This derivative minus sin phi cot theta, and then partial phi. Okay, and the expression for Lz was h bar over iota into curly over curly phi. So now you have to plug in these values and you have to simplify them, right? Okay. So I would like you to do this in your notebook so that we can then do it together and we can arrive at the result. So putting in these values, what should we get? So you can plug in these values and you can then simplify it. And the final result you will get should be L squared is equal to minus H bar squared into 1 over sine theta into curly over curly theta into sine theta plus 1 over sine squared theta into curly squared over curly theta squared. Okay, so this is the expression we should get. Taha? Hello, Taha. Taha, are you there? Taha, please switch on your mic. No, you have to speak. Switch on your mic. And hello, Eamon. Eamon Nadeem, are you there?
यस मैम इधर ही हूँ वो तहा का मैसेज आया हुआ है उधर कि उसका माइक नहीं काम कर रहा दैट्स व्हाई इज नॉट सेइंग एनीथिंग
So the message for you, Eamon Nadeem, is that I've not received the topic that you were supposed to submit. ठीक है ना?
मैम वो जब मैंने वो सबमिट किया था ना टॉपिक तो मुझे मूडल में कुछ मसला आ रहा था तो मैंने आपको मेल कर दिया था उसी दिन
Eamon,
आई ट्राई मैं अभी उसको फिर उसमें भी अपलोड कर देती हूँ बट मैंने आपको मेल उसी दिन कर दिया था
Eamon Nadeem, what's your topic?
क्वांटम टनलिंग
No, Eamon Nadeem, that's taken already. Eamon Nadeem, that topic is already taken. You have to find another topic. You can choose something we discussed in class, okay?
ओके मैम आई विल सबमिट टुडे
Okay. And Taha, because you have to start working on the paper because your deadline is getting near, okay? Taha, what's your topic? I've not received your topic. So students who have not submitted their topics, they have to do so as soon as possible because you have to start working on the papers, right? And you have to communicate the topics and you have already crossed the deadline, right? So of course there will be a penalty for that. And students whose topics are confirmed can of course continue to work on their topics. Okay? Right, so we come back now. Okay, we come back to the board. So once we have this value of L squared, we can now use it further. We can start working on the eigenvalues and eigenfunctions, okay? So we're going to, you can complete these steps that I left in between, okay? So all you have to do is to plug in the values of Lx, Ly, and Lz, take the squares, simplify them, cancel them, and so on, and you will arrive at this expression, right? So the next thing that we have to do is we have to find the eigenvalues and eigenfunction of the operator Lz, okay? So in this case, let us assume again like psi denotes the eigenfunction and lambda be the corresponding eigenvalue. Then we can write the eigenequation in this form. The eigenvalue equation will be so we've already worked with Lz before in the previous classes. So we know that Lz in spherical polar coordinates, just as I've written above as well, is given by this equation. Now, when we put this value in the above equation number 1, we will have this expression, right? Uh-oh. So this can also be written as, rearranging it, we can say we get this expression. And again, now it's easier to integrate. So when we integrate so integrating both sides, what do we get? We get the natural log of the function, and this is equal to multiply by phi plus the natural log of t, where we have assumed that this expression is an integrating constant. So now we can rearrange and we can write it as we can have both terms on one side and we get this expression psi over t is equal to the exponential of iota lambda over h bar into phi. So therefore the eigenfunction is then written as p multiplied by the exponential term, which is iota lambda over h bar into phi. So this is the function we have to find. So this gives the eigenfunction phi, psi, and this function is acceptable only when it is finite. Along with being single valued and non-zero. So if psi is single valued, then psi phi is equal to psi phi plus 2 phi. Hello. Yes. Okay, so when we equate this, we can of course substitute the values that we had found above, right? So this is equal to, again, putting this value. Okay, of course you can cancel P on both sides. And after cancelling that, you will have exponential iota lambda h bar phi is equal to exponential. You can separate these as multiple of two exponentials. And we know that the second term will be equal to 1, right? We know that this one is equal to 1, right? And we also know that e raised to 0 is equal to 1, right? And we can write this as e raised to 2 pi iota is equal to the sum of the cosine of 2 pi and the iota multiplied by sine of 2 pi. So this is equal to 1. Similarly, we can write and this will also be equal to 1. And another multiple that can be written as plus minus 4 pi iota. Again, these are multiples of the exponential of 2 pi iota, right? So this will also be equal to 1. Therefore, we can equate these as 2 pi iota lambda h bar is equal to 1 is equal to e raised to 0 is equal to e raised to plus minus 2 pi iota is equal to e raised to plus minus 4 pi iota and so on. So when we equate these powers, on both sides, we get the 2 pi iota lambda over h bar is equal to 2 pi mi. And then we can have lambda over h bar is equal to m. And therefore, the eigenvalue that we assumed in the beginning will be equal to a multiple of h bar. So in this case, m is an integer. And so on. So therefore, we have found the eigenvalues that we wanted to do. So the eigenvalues of Lz are So minus 2 h bar minus h bar 0 h bar plus 2 h bar and so on. So this can be called a spectrum of eigenvalues. And M, as you know, in quantum mechanics is called the magnetic quantum number. Okay, hello Asad. Asad, are you there?
Yes, ma'am, your voice is breaking.
Huh?
Ma'am, I'm unable to understand because my internet connection is unstable.
Okay, anyway, you can see here that the reason for choosing h bar rather than h is that when quantization takes place, normally it's a multiple of h bar, h over 2 pi. So that's one of the reasons. You know, in one of the previous classes, you were asking about this. You remember? So, Asad, are you there? Okay, so as we can see now, this meeting is going to end. So let us disconnect and join with the same link again, okay? Is that clear?
Yes, ma'am.
Okay, so let's disconnect this meeting and join again with the same link.